September 23rd, the first full day of fall. The equinox was yesterday, and you're seeing the remains of Tropical Depression Beta. It's down to 30 miles an hour, moving into Louisiana this morning with a pressure of 1007 millibars. So that's just out of the picture, but it will lay down a track of rain all the way to Georgia. And we can also see Teddy up there crossing Nova Scotia. The wind's still up there at 60 miles an hour, but the rest of the Atlantic Basin looking pretty good. The 5-day tropical outlook has quiet conditions in the Atlantic, the Gulf, and the Caribbean. This time of year, being September, the ocean basins are at their maximum temperature. It's a good idea to look at the precipitable water. And we can see that for the most part, it's pretty dry across the U.S., with the exception of the northwest coast, where we have a new baroclinic system coming on shore, and of course, the remains of Beta still wandering across Texas. Let me bring this up to the current time, 18Z. And you can see that plume there, wrapping up into Mississippi, into Louisiana. And there's also this dry slot, which is still in place across the western Gulf. And just checking a couple of other patterns real quick. We've got, looks like high pressure across Manitoba. This looks like a new outbreak of cold air coming south. Further south, we have a stagnating high pressure area across Kentucky down to the Carolinas. And as a result, we're getting a circulation kind of like that. Comes around easterly into Texas and then around to the south in Iowa and the Midwest. So this is kind of going to be its own air mass there. And of course that will be feeding into the backside of Teddy going across Nova Scotia. What other air masses do we see? Well, we can look at the low pressure offshore, the northwest coast up here. There's a low way up there off Victoria Island. So that's going to be bringing a southerly flow through Washington and Oregon, all the way up into British Columbia. And that's going to be coming from just a very vague, weak high across the Great Basin, extending into kind of a warm Pacific high off the California coast. So as a result, we get a flow kind of like that, and then feeding into the interior regions of California. And I can see another tropical storm way off to the south, off Baja California. Lowell, 50 miles an hour. Yeah, we don't look at this area too much unless we're expecting weather to come into Arizona or California. And that does not seem to be the case. So it's fairly evident the main thing we're going to be concerned with today is the remnants of Beta. And you can see that track in there across Louisiana. And by this evening, it should be entering Mississippi. So it will have a little bit of convection associated with that. SPC, they're looking for just a marginal risk in Louisiana and southwestern Mississippi. They're looking for high dew points to advect inland. That'll bring those theta E values up quite a bit and push the capes up to 1,000. And whenever you're near 1,000, there is a little bit of severe risk with that, because your velocities in the updraft are strong, and that corresponds to an increased risk of severe weather. And curved photographs. Let's look for that. That's easy to find on the high-resolution rapid refresh. The best thing to do is bring this up to the time of maximum heating, about 22Z. You want to make sure you're away from the main convective elements. You want to kind of sample the air out ahead of it. So maybe that spot right there. And I take a quick check here and make sure we're not getting any omega spikes. That's these red lines. If they extend well out to the interior of the chart, that would indicate that we're sampling a cloud, which is contaminating the results. So this looks pretty good here, and oh yeah, look at that photograph. That's curved for sure. 0 through 1 kilometer shear. Got about 30 knots of shear there with curvature, and this is the storm motion. That's indicating the storms are moving from 210 at 20 knots. And that's just, using this as a origin on the vector and this on the head of the vector. And that's moving towards 030. That's why we find it on that side of the photograph, on this quadrant here. So that gives us a motion that kind of wraps around the photograph trace, and because of that, that's a good setup there for rotation. So certainly I would expect to see a chance of supercells in eastern Louisiana and southwestern Mississippi, pretty much as they outlined on the SPC Outlook. The main problem is the lack of capping, which means when any cells go up, there's going to be many more of them joining. And when you get a lot of cell competition, it's hard to get those sustained windows of mesocyclone development. As a result, any tornado activity would be probably brief, small structures, that kind of thing. However, the tail end, as indicated by the high-resolution rapid refresh model here, that could bring an increased risk of a strong supercell. So we may have to watch that area, looks like St. Francisville up to Macomb. However, there is also some element of uncertainty in the model. So even though it's showing this for a solution, there could be elements down further south. As an example, let's look at the Nissel WRF. So this is a run from this morning of a different model, and you can see that there's a slightly different picture here. So we're not seeing one big cell tracking through that part of Mississippi. In fact, it looks like it's a little further north. So that kind of widens out our area of concern. Another model is the WRF ARW. I like that because it has some very detailed microphysics. And this one has the convection pretty similar to the high-resolution rapid refresh model. So yeah, that may be kind of an area we have to watch. And then of course any of these cells around Slidell up into the northern counties of north of New Orleans, those could also get going. Just to give you some idea of the environment out here, we're back to the HRR, by the way. I'm going to drop a sounding near Slidell, and you can see that even though it's not indicating thunderstorms, we definitely have a curved photograph and good potential there for rotation. Now once again, air mass is relatively uncapped. The capes are up to 1,500, but we really don't need a whole lot if you have sufficient SRH. And yeah, we do. The other factor I might be looking for is whether we're going to get a window of heating. If the clouds break up a little bit, that could be an issue. So we're bringing this up to 1920Z. And yeah, there is some heating. Temperatures coming up to 80 degrees. So, based on this, I might be looking at upgrading that to a slight risk if I was a forecaster at SPC. Definitely not a moderate risk or anything like that. And the satellite does bear that out. You can see the clearing taking place. You can see what looks like transverse bands out ahead of this little feature here. And I would look for maybe some of these rows here to become a little bit more vertical as the day goes on. And there's theta E, where you kind of put temperature and moisture together. The higher the theta E, the further your lifted parcels will be on the right side of the skew-t. So this is around the time of max heating, so that would be the area we're most interested in. And that kind of transects that area of development, so that kind of gives you the focus for late this afternoon. So we shall see what happens. There's a few favorable things: low LCL, high SRH, modest CAPE, and there's also a few negative factors such as the lack of capping and weak bulk shears, which will work against the potential for long-lived cells. There's the surface map for this afternoon. Yeah, I think this is kind of developing into a frontal system. There remains a beta down there in Louisiana, and that gives us a kind of a warm front feature through that area of concern. And that divides this 81 over 72, that's very sultry air, from the cooler conditions up to the north. And of course, with that broad easterly flow there, that's kind of primed the SRHs a little bit. Out in Texas, northerly flow pulling in behind, bringing some slightly drier air south. And then up to the north, we have the stagnating cold air mass from a few days ago. This is neither continental polar, it's not any of these air masses. It's kind of just a big stagnating blob of cold air sitting up there in the Midwest. And that will continue to modify over the next few days, and then it should lose definition. And just a quick look at the satellite there. We're definitely expecting rain throughout the south as that system tracks northeast. And it will behave a little bit like a cold front lifting up out of the western Gulf area. A nice day in the northeastern U.S. Cold air advection once again in New England into New York. Classic stratocumulus there, and even some gravity waves. And a little bit of fog being indicated over the Great Lakes. The water temperatures in that area in the low to mid-50s. So when we get the strong moisture advection taking place over Wisconsin, Michigan, you can see those dew points are in the lower 60s, which is quite a bit higher than the water temperatures. So that means you're going to chill the air mass down to below its dew point, and you're going to produce fog and stratus. And that's what we end up with in the Great Lakes area. And when we start bringing the really cold air down later this fall, the warm water temperatures are actually going to increase the instability of that air, and we'll start getting the lake effect snows and even the development of explosive cyclogenesis over the lakes. The Edmund Fitzgerald, November of 75, I think it was, that's a classic example. And out to the west, kind of a weak system over the Dakotas. Probably with this very strong moisture coming up to the north, we may see some potential for storms in Minnesota and Wisconsin. It's starting to get active in the northwestern U.S., but we don't quite have a system onshore just yet. Can definitely see that the coastal regions are under southerly flow, and we're getting gusts up to 30 miles an hour. Well, actually, that's 30 knots, so that's 35, 36 miles an hour along the Washington coast. And there it is, the visible satellite imagery in that area. Looks like mostly just mid-level systems moving across the northwest. But this is a pretty well-developed system, and if I take a look out over the Pacific, yeah, here we get a better look for sure. This is all cold core stuff. This is going to be back behind the frontal system, and this is likely a baroclinic system moving in. So I would be looking for maybe a setup, something like that, maybe further north. And I can use that to kind of modify the surface analysis. It looks like some very well-developed convective elements way up there in northern Victoria Island. So there's a quick revision to the surface map. I think we're looking at something like that for Washington. And pretty quiet in the southwestern U.S. This is pretty much a series of plateau highs in the Great Basin and Intermountain region. And then we have a heat low there in Arizona. I don't see any more evidence of that easterly flow in the Rio Grande, so I think we're pretty much done with that old stagnant stationary front. So this is probably the start of a slow warm-up for the southwest, and that system way up there in Oregon will probably continue moving to the east or northeast, bypassing this region. Clear skies on the satellite. What more can you say? So that'll do it for this edition of Forecast Lab. Thank you for joining today, and we'll see you tomorrow. Bye-bye.